Very good afternoon. Today we are going to discuss computational complexity of algorithms. It is a very famous topic in computer science and also very interesting topic, computational complexity. In computer science, we generally deal with solving problems. So the main objective of computer science is to provide solutions to the problems. There are very large number of problems available and computer science has always been trying to find solutions for those problems. The problem is that while providing solutions to the problems, the computer science is putting with a lot of efforts. But there is a possibility that suppose I am a computer science engineer and I am going to solve a problem. I am putting so much effort to solve a problem, and after spending 1 month of my precious time over the problem, I came to know that this problem cannot be solved. That means 1 month of efforts have been gone in vain. There is no use of that effort. So what if initially I had a procedure to know that this problem cannot be solved, or there is a process to check whether the problem is solvable or not. If something like that is available, then before going to solve a problem, I will first go and check whether this problem can be solved or not. Then I will start putting the efforts. This is why we need to study computational complexity of the algorithms or the problems. So there are many problems to which we need to find solutions, and these problems have different computational complexity. In general terms, we can say complexity is difficulty. How difficult the problem is to solve. So there are several problems, and all the problems have different level of difficulty. So the problems have been divided in classes. So initially we are going to discuss 3 classes: P class, XP class and R class. We are going to divide the problems in these 3 classes. What is the meaning of P class problems? P class problems means the problems solvable in polynomial time. The problems which are solvable in polynomial time is P class problem. The problems will be put in this set P. EXP or XP, the problems solvable in exponential time. By exponential we mean n 2 raised to power n raised to power c. For example, 2 raised to power n square or 2 raised to power n cube, something like that. So if we have, suppose we have a line of difficulty where from going left to right the level of difficulty increases. We can have 4 stops here on this difficulty line. This is P. So all the problems which are in class P are here on this difficulty line. This is computational difficulty. Computational difficulty. This is another level of difficulty, and I will come to this after some time. this is XP. That means every problem which is in P is also in this set XP. That means if it can be solved in polynomial time, then definitely it can be solved in exponential time also. And this is R. What is meaning of R? R is problems solvable in finite time. R generally stands for recursive. In initial stages of development of computer science, the engineers tried to find solutions to some problems and they wrote recursive solutions. So if a problem has a recursive solution, then the problem is solvable in finite time. If the problem does not have any recursive solution, then the problem does not have any solution. It cannot be solved in finite time. This is why this class R is developed. So we are going to understand these classes by examples. Suppose I am going to run this. We are going to take some examples and we are trying to understand that these example problems, which of these example problems will fall in which of these classes. Suppose first problem I have taken is negative weight cycle. Negative weight cycle in a graph. That means I have to detect whether a graph contains negative weight or not, negative weight cycle or not. So this problem can easily be solved using Bellman-Ford algorithm, which runs in order of E into V time. This is a finite time, that means this problem belongs to class P. So the next problem we are taking is N cross N chessboard. So suppose we have to answer that from a particular state. If I ask, does white win from this state? So this problem comes in exponential class, XP class, and there is no polynomial time solution to this. Third is, suppose we have a game Tetris. Very interesting game. So if I ask that we have to decide by which moves can we survive the game. So this problem also can be solved in XP time, but it is not known that whether it is in P or whether it is not in P. This is not known. So that is why we are saying that Tetris lies at this point. The fourth problem is, suppose halting problem. Halting problem is, if we are given a program, the question is whether this program terminates or not. So there is no such algorithm that can decide whether a program is going to terminate or not. That is why halting problem lies here, beyond this boundary of R. Halting problem is not part of R also. This class after P, this class is called NP class. This class, the problems which are lying here are called NP. The biggest question is whether P is equal to NP or P is not equal to NP. In the next class, we will be discussing this and we will be defining NP in more detail.